All right, next up we have Chapter 2, Section 2, the slope of a line and rate of change. Here. All right, so pretty sure this leads into example 1. So we're gonna try and fit all of this in here. Okay. Yeah. Alrighty. So, lots to read here, but just follow along. So we've got introduction to a slope of a line. We have already learned how to graph a linear equation and to identify its x and y intercepts. In this section, we learn about another important feature of a line called the slope of a line. Geometrically, slope measures the steepness of a line. Right? Naturally, it doesn't show the figure. Right? So let's skip the stairs part and jump straight to this other figure here. Well, not necessarily. We can still talk about this. Right, so to measure the slope of a line quantitatively, consider 2 points on the line. The slope is going to be the ratio of the vertical change between the 2 points to the horizontal change. Okay, now that's a mouthful, but just bear with me here. That is, the slope is the ratio of the change of y to the change in x. As a memory device, we may think of a slope as a line of rise over run. Okay, so it's just going to be it's going to be the rise or the run, or the fall over run, but we'll talk about that momentarily, right? So to move from point A to point B on the stairs, rise 3 feet and move to the right 4 feet. Again, that's the figure that is not shown. Right? Okay, so here we go. So we talk about figure 14 now. So down here, to move from point A to point B on the wheelchair ramp, rise 3 feet and move to the right 18 feet. Okay, so we see here. Okay, so we have this is a wheelchair ramp. Okay, it goes up 3 feet in this okay, I can phrase that better. it runs 18 feet in the time it takes to go up 3 feet. Okay, but since slope is defined as the ratio of rise over run, we are rising 3 feet in the time it takes us to go 18 feet. Okay, so therefore, my slope is 3 over 18, or in other words, 1/6. Okay, so that is the slope of that. So in this particular, found the slope of the ladder against a wall. Is there anything else to that? We don't see a ladder. Okay, so we don't see a ladder anywhere. So with that said, we're going to skip that right there. Okay, so I'm assuming maybe, am I missing something? Found the slope of a ladder against the wall. I don't know. I do know that we're also going to skip example 2 because example 2 leads to example 3, and example 2 just doesn't have enough substance for me. But we will talk about the slope formula. That's interesting. All right, so the slope formula. So there's going to be a lot of formulas that we're about to learn, and they're going to go really fast. Okay, and I've got bad news. There's really no other way about it. You have to memorize these equations. All right. So starting from the top, where's my pen? Oh, that's not a pen. There we go. My laser, rather. So the slope of a line may be found by using any 2 points on the line. We're going to call these points x1, y1, and x2, y2. Okay. So the change in y between the points can be found by taking the difference of the y values. The change in x can be found by taking the difference in the x values. Okay. The slope of a line is often symbolized by a letter m and is given by the following formula. right? The formula is, it doesn't say it here. It's y2 over y1. I guess it's an implied formula. Or did I not snip enough? Okay. Well, we'll do it this way. It looks like it's an implied formula, which isn't good for teaching students that don't know what slope is. So first of all, let's tackle this right here, this and this. Okay. I know that, especially when I was a student, the further away you get from using numbers, the worse it seems, right? But once you calm down and realize that letters are needed to solve equations, things begin to make sense, right? And while I'm on this tangent, we use x, like x plus 7 is equal to 11, right? And of course we know what the answer to that is, right? But my point is we use variables because we can't just say question mark, right? Question mark plus 7. So that's why we use variables, and variables just mean an unknown. So I have heard many people say that they don't like letters in their mathematics, but it's just basically like a question mark. Okay. Anyways, back to what I was talking about. Okay, we see x1 and y1 and x2 and y2. What this basically means is we're going to have 2 points. Okay, we have 2 points, and we're going to denote them as point 1, point sub 1, and point 2, p sub 2. Okay, and the points in p sub 1, right, we know that they're going to have that the coordinates are x and y. We know the coordinates over here are x and y. Okay, the whole point of those subscripts right here, the 1s and the 2s, is so we can distinguish the points from one another, or the x and y values from each other, the 2 different points, right? So x1, y1, that means we're talking about point 1, okay? The subscript, the 1s, don't mean that we're talking about point 2. And hopefully that makes sense, because I feel like sometimes I over-explain things and make things 10 times worse, so I'm going to stop there. That will be a theme that you notice throughout the semester. Okay? So let's go ahead and talk about this implied slope formula that I was talking about, okay? So we have, it says that m is the word that the letter we use for slope, or the variable we use for slope. Okay, so it does seem kind of weird, right? We have m for slope. Well, if I recall, it's like the French or Italian word monter, which means to climb or something like that, right? So that's why we use m, monter. So what we're doing here is it's going to be the change in y. So y. So the difference in the y values over the difference in the x values. And that's it. That is the slope of a line. Oh, what is going on? Okay, so I don't know what it is. My desktop. So for right here, we see the definition just cuts off. My desktop doesn't cut off there. I wonder if it's because I'm in tablet mode, which really sucks if that's the case. But we'll just put this right there. Okay, because that is the slope of a line, and that's the definition of slope of a line. We have the difference in y over the difference in x, and I'm hoping. Well, I mean, I know it does. So, well, if you're on a tablet, and you're looking at the textbook, I don't think things are going to show up correctly for some reason. I don't know why, and I will contact some people about this, because that's super unfortunate. Because as a student, if you were to do this on a tablet and you see this, the slope of a line passing through the distinct points x1, y1, x2, y2 is, you can be like, okay, is what? I don't know, I find it funny. We'll work through it together, all right? So we can actually go to the examples. So we're going to jump straight to 3, okay? Because example 2 didn't really have too much substance to it, I think. Okay, so we'll snip those words as well. Alrighty, so this reads, when you apply the slope formula, you will see that the slope of a line may be positive, negative, 0, or undefined. Okay, and I'm pretty sure we'll touch on all those. Lines that increase or rise, okay, so lines that go up like this, because we read a graph from left to right, right? We call that a positive slope. Lines that decrease, right, or go down like this, all right, we say those have a negative slope. Just straight up horizontal lines, we call those, we say that those are 0 slopes, and then vertical lines, we say that those are undefined. Okay, and again, we're going to touch on all these, pretty sure. Okay, first things first, this particular equation we've got, it reads, find the slope of a line passing through the points 3, -4, and -5, -1. Okay, so this will give us a good example as to why we use point 1 and point 2. Okay, so we're just going to go in order, right? So we're going to say P sub 1, we're going to mean point 1. P sub 2, we're going to mean point 2. Okay, you don't have to do this every time, but until you get a good grip on this, I do suggest it. Okay, so P sub 1, we're going to call 3, -4. Again, we're just going to go in order, left to right, the same way that the problem is given to us. And point 2, we're going to say -5, -1. No, let's do this. Okay. Alrighty, and if you recall, and I'll go ahead and put the slope formula here so you can kind of follow along. It is y2 minus y1 all over x2 minus x1. Okay, so if we were to kind of denote this, right? This is x1. This is y1. These are the this is the first point, so they're going to be noted as x1, y1. This is the second point, so it's going to be noted as x2, y2. Okay, so when we kind of fill in for this particular equation, right? We're going to say m is equal to, okay, so y2 minus y1, so y2 is a -1, and it's going to be minus a -4, so we got a negative, so make sure we put ourselves a parentheses there, and it looks kind of awful. That's just what it's going to be. Touchscreens, right? Right. So we're going to have a -1 minus a -4, and then we're going to have a -5 minus a 3. Okay. So the arithmetic here, -1 minus a -4, that's -1 plus 4, so that's going to be a 3 over -5 minus 3, which is going to be a -8. Okay. So there is one little pro tip that I would like to give you, and that is whenever you have something that looks like this, right? We have a 3 over a -8. All right, well now 3 over -8, there's nothing technically wrong with 3 over -8. It's just it looks kind of weird. Okay, so what I would suggest you do is put the negative sign in front of everything. All right, now this is a good habit to get into for for this class and for every class after it. Okay, so we could simply just say this is going to be negative 3/8. Okay, so all I did was just simply put the negative in front of it, right? And that is the slope of this particular line. Okay, and of course it is a negative slope, so therefore this line is going to be pointing downward. It's going to be going down. Okay, example 3. Example 4, we're going to find this slope. And again, I'm just going to keep putting the slope formula here, because it's one of those formulas that you're just going to have you just have to memorize. There's no other way around it. Okay. But this particular time, I'm going to go a little bit different. Okay, I'm not going to do the whole P1, P2 thing here. Okay. Now, again, you can if you want to, but I'm also going to go about it a different way. A different way being, I'm not going to say quicker, but just one where it's less writing. Okay. Again, I suggest you do it like example 3, but if you do it like this, that's fine too. Okay. So I know that this is going to be point 1, and this is going to be point 2. 0.1, 0.2, okay? I mean, realistically, it doesn't really matter what you call what. It's just as long as you're consistent. And the thing is, I just read my problem left to right, so my points are left to right as well, right? So, I mean, it's similar to probably how y'all's are going to be. So what we're going to say is y2, which is a negative 2, minus 4 over negative 3. I'll tell you my 3's. Negative 3 minus a negative 3. Okay, so negative 2 minus 4 is going to be a negative 6 over a negative 3 minus a negative 3, so it means plus 3, so we're going to have a 0 here. Okay. All right, now if you or your parents, okay, if you or your parents have ever learned anything in mathematics, I bet your parents might remember the Pythagorean theorem, and I bet they remember that you cannot divide by 0, right? So this slope is undefined. So we would say that the slope is undefined. Okay, and what did I say an undefined slope was? I said that an undefined slope was a vertical line. So if we look here, ooh, you know what? I probably should have snipped that for the previous example as well. So let's go back and put that graph in there. Okay, there we go. So I said that, you know, on the previous example, on this example here, I said that it had a negative slope and it went down, and we do indeed see that it is going down. Okay. And then for this particular example, this is what an undefined slope looks like. It is simply a vertical line, right? It's undefined. Right. And it kind of gives I give away the solution, right, when I want to do this, but oh well. So same thing. Let's go ahead and do this. Yeah, let's go ahead and do that. I was going to maybe try and shave off, you know, maybe not putting the formula up there, kind of like how I didn't do 0.1 and 0.2, but I feel like I really drive home the importance of memorization if I write it each time. Okay. All right, so here we go. We've got y2 minus y1, so we've got 2 minus 2 over, and then x2, so a negative 4 minus 0. Okay, so this means 2 minus 2 is 0. Negative 4 minus 0 is negative 4. Okay, well, so I've got I've got the slope 0, negative 4. Okay, well, this is a 0 slope. Okay, or let's see, what would we call it? Yeah, okay, we did call it a 0 slope here. Okay, a 0 slope. All right, the example earlier was a vertical line. We called it undefined. Okay, a horizontal line is going to be a 0 slope. So let's go ahead and snip this, and we'll get a better understanding here. Okay, so yeah, those 2 points. So these 2 points are here and here. Okay, we see that it is indeed a horizontal line, and horizontal lines have a 0 slope. Alrighty, so this reads, lines in the same plane that do not intersect are parallel. Non-vertical parallel lines have the same slope and different y-intercepts. Okay, so that makes sense. Lines in the same plane, you know, in the particular case, we're also talking about oh gosh, I forgot what it was called, the rectangular coordinate plane. All right, they do not intersect. We know that they're parallel. Of course, we're familiar with the word parallel. I'm sure we've used it quite a bit in our lives, right? Well, if they don't intersect, these lines are parallel. Lines that do intersect at right angles, okay, and it has to be at right angles, then those lines are called perpendicular. Okay, well, how do we figure out the slope of a parallel line and the slope of a perpendicular line? Well, as I said, parallel lines have the same slope. Notice how these two lines, their slopes, you can hardly see it, I guess, but I think they say 5/3, okay? They have the exact same slope, therefore they're parallel. And that is what this definition says, right? If M1, again, the slope of 1, and M2, the slope of 2, represent the slopes of two parallel non-vertical lines, then M1 is equal to M2, meaning that their slopes are the same, okay? And then here we have the slopes of perpendicular lines. All right, so let's look over here. This line is perpendicular. We see that the slope of line 1 here is -7/2, and the slope of line 2 here is 2/7. Okay, so notice how the numbers are the same. They're just flipped, right? One is 7/2, one is 2/7, and notice how one is negative and one is not, right? So in order to figure out the that slope of a perpendicular line, they are the negative reciprocals, okay? So reciprocal basically means that we're taking a fraction, a over b, and we are flipping it upside down to b over a, okay? And then put the negative sign in front. Okay, so let's change that to negative b over a, okay? And I think that's pretty concise. Well, this is concise, but this is more of the cornbread language that we're used to, huh? It's just, we just take the negative reciprocal of it. All right, so let's get into some examples here. Okay, so for A, it says find the slope of a line parallel to the given line. Okay, well, the given line has a slope of -5. Well, that's pretty easy. Then this slope is going to be -5. Okay, or let's say m is equal to -5. Okay, and then B, find the slope of a line perpendicular. Okay, so here's the rub here. This is a -5. Okay, so -5. If I were to essentially write -5 in a fractional form, I could say -5/1. Right. Well, if I were to flip it upside down and change the sign, then it would be, it would be 1/5. Okay, and that's it. You just take the slope and you just kind of flip it on its head. That's about it. Yeah. Oh, and you change the sign. If it's positive, change to negative. If it's negative, change it to positive. Okay. And now this is the culmination here. So this reads, determine whether two lines are parallel, perpendicular, or neither. Okay. So what I need to do, I've got these two lines here. I need to figure out the slope of line 1, so I need to figure out m sub 1, so that means the slope of line 1, and I'm also going to need to figure out m sub 2, which is the slope of line 2. Okay, so let's get on that. All right, so same thing, I'm just going to, I know that, or you know, in my mind, okay, you can do it differently, but to me it just makes more sense, or it makes a lot of sense to say the first ones will be 0.1, the first points, and the second points will be 0.2. Okay. Now there is something to be said to make the arithmetic kind of easy on you, because you might want to have like the positive number first. But to me, I think that's just something that you just kind of get the hang of, and something that you'll do as you proceed. Okay. All right. So here we go. So we're going to say 1 minus a -3. Okay, and then we're going to have a 4 minus 2. Okay, so here we go. This is the 1 right here. This is -3 right here. It's a change in y, right? y2 minus y1. And then we have the 4 right here, and then the 2 right here, which is a change in x. So the change in y over the change in x. Okay, so we'll have 1 minus -3. Well, 1 minus -3 is simply saying 1 plus 3. So that's going to be a 4. and then 4 minus 2, that's 2. So my slope of line 1 is going to be 2. Okay. So I don't know what the slope of line, or I don't know what the second line slope is just yet. But if it's the same as line 1, we know it's parallel. If it is the negative reciprocal, we know that it is perpendicular. And if it's neither of those, then it's going to be, well, it's going to be neither. Okay, so let's go ahead and do 2. So we're going to have a negative 2 minus a negative 6 all over negative 3 minus 5. Okay, so what is negative 2 minus a negative 6? Well, that's simply saying negative 2 plus 6, so that's going to be a positive 4. And then we're going to have a negative 3 minus 5, which is going to be negative 8. Okay, and if we simplify this again, let's go ahead and put the negative in front because I really want you to get into a habit of doing that. So we have a negative 4/8, or in other words, we have a negative 1/2. Okay, so let's go ahead and box these in here. Okay, and then you're going to ask yourself, okay, so are these the same? Well, obviously not. Okay, are they negative reciprocals of one another? And the answer is yes, right? Because obviously the signs are different. One's positive, one's negative, and the fraction is indeed flipped, right? Because if I were to write 2 as a fraction, it would be 2 over 1, right? And the reciprocal of that is 1 over 2. So we can say that these two lines are perpendicular. And you know what? Let's just write perp. Right? They are perpendicular to one another. Right? And that concludes Chapter 2, Section 2.